Good day. Stress analysis is a very hot topic these days, especially with everyone trying to reduce his project cost without sacrificing the quality of the project. Many times I had been asked when and why should I do stress analysis to my piping system. This question was asked by project owner, project manager, even by piping engineers. My video today will explain to you when should you ask piping stress analysis engineer to perform a stress study for your piping system. Before starting the video, it will give me a great pleasure and support to subscribe to my channel and press the notification bell for more updates about my new videos. I'm Ahmed Ibrahim and let's start our presentation. Let me give you a quick introduction about piping. Piping system is the most efficient and common means for transporting fluids from one point to another without petrochemical complex. In petrochemicals or in the process planet, piping constitutes 25% to 35% of the material of process planet. It requires 30 to 40% of erection labor. It consumes 40 to 48% of engineering man hours. This for process planet. For power plant, it requires for 20% to 25% of the material and 30 to 35% of engineering man hours. Those power plants have more equipment, which is more expensive. The piping system is designed in the following steps by different engineering disciplines. Process engineer in the beginning produce the PFD and make the process study. Then the material specification engineers assign the material and start to creating the piping specs. After them, the system engineer took the PFD and the material specs of the material assigned list and start to produce the P&ID, which is the process and instrumentation diagram. After that, it comes the role of the piping designers to start routing the piping in the model and start build the model. After completion of 30% of the model routing, piping stress engineers start to review the model and start to process in their studies. And all the duration of the project, the coordination between the piping engineer and the piping stress analysis engineer is continue to reach to the optimum design of the piping system. The purpose of the piping stress analysis. In general, the purpose of the piping stress analysis can be summarized in two broad categories. Ensure structure integrity, maintain the system operability. This involving the structure integrity, this involving the calculation of the stress in the piping due to all design loads, which is, we will talk about it later. Maintain the system operability or operation. The piping itself can be very strong, yet the system may not be operating due to problems in the connecting equipment, flange leakage, valve stick, high stress in vessel nozzle, and exceeding the piping loads or the piping allowables for the rotational equipment, especially pump, always have a very low allowable stresses. In the far beginning, when engineers started analyzing piping systems, they had only one thing in mind, calculating the stress due to thermal expansion. But by days and by studies, the main failure or mostly failures are caused by vibration, thermal bowing, creeping, thermal fatigue, and this is a very hot topic, thermal fatigue, water hammering, steam hammering, and a lot of other stuffs which we will go on in the future videos. which will be explained in the future videos. Okay, analyzed and non-analyzed piping, which is, we mentioned it's critical and non-critical piping. Piping system is divided in two categories for thermal expansion analysis as following. Detailed thermal expansion analysis are required for all Group 1 piping systems, piping stress, and piping support loads, and nozzle equipment loads are to be calculated and appropriately qualified. This analysis or this group based on temperature. And our main criteria here was the temperature. For carbon steel and low alloy steel, we start to consider critical piping once it reached to 204 Celsius and above. And for stainless steel, once it reached to 148 Celsius and above. Detailed thermal expansion is required for selected group 2 piping systems only. These systems require detailed analysis due to their operational importance or connection to major sensitive equipment. For power plants, we have feed water system, extraction steam, low pressure steam, fuel gas considered for power plants and process plants, piping attached to sensitive equipment, as I mentioned before, pumps, shell, and heat exchangers, piping systems with expansion joint and relief valves, cross-country steam lines or oil pipelines, large lines 16-inch and larger, the blow-down flare header systems, all the jacketed lines. All the systems shall be reviewed and computer run may be made without a detailed analysis. No formal documentation is required for these systems. But let me tell you something. Not always formal documentation not required. Sometimes it is requested based on the client requirement and based on his criteria. Piping stress analysis documentation. We have a required documents and a deliverables. The required documents is a system description, the PNID, the equipment specification drawing, which located on it table for the nozzle allowables, and this is a must, and if it's not existing in the drawing, you need to ask the vendor for it. The line designation table, the LDT, system operation modes, and this is important to understand how to make the simulation inside your model, because after all, we make a static simulation to know the forces and the moments that existing on the piping, and also the piping, and of course we need the piping isometric, piping class sheets, valve specification, tie-in piping design drawings, site condition, which is including the wind velocity, seismic zone, if we have a snow, rain level, site plan and plot plan, general arrangement drawing, safety and relief valves drawing and data sheet, and this is important if you need to make a dynamic analysis for the relief valve, and control valves drawing with data sheets. Both 12 and 13, you need to know from the process engineer the timing and the duration of the valve opening. What will be our deliverable? First of all, a full static analysis report. And the full static analysis report should consist of a summary for for all the report, introduction and the scope of work, the regulation codes that we are using, the design basis that we considered our calculation on it, the design consideration, the load cases that had been used, the results, and conclusion of the results, and appendices. This appendices will consist of the piping stress isometrics, index, the piping stress isometrics, the 3D shaded plots, which is you need to make the 3D shaded plots from the software. Copy of the line list the lines that contain the lines that we are using. Pressure vessels and equipment drawings. If we will perform a finite element FEA, you need to put the input and the output file. If you need to perform the flange leakage test, you need to put the calculation and the results. If you have a pressure safety relief valve, you need to also to include the calculation. If you will make the expansion and slip-on flange, you need also to include it. Flare tip ignition, hydraulic hammer and surge load, slug load, pump, compressor, and turbine combined nozzle loads, which is considered all of the and nozzle shell flexibility, all of this considered a dynamic from starting from PSV, all of this is considered a dynamic analysis. Also, you will need to provide the support load list, spring support selection list, and expansion joint list. Stress categorization. Stress analysis is categorized to three main categories. Primary stresses are those developed by the imposed load and are necessary to be satisfied the equilibrium between the external and internal forces and moments of the piping system. Typically, loads are dead weight, internal pressure, sustained stress are primary stresses. Primary stresses are not self-limited. The secondary stresses are those developed by constraining the free displacement of the piping subjected to thermal loads, or imposed displacement from movements of anchor points, etc. Hence, thermal and displacement stress are in the secondary stress category. Secondary stresses category are self-limiting. Peak stresses. Unlikely loading conditions of secondary stresses which cause distortion. Peak stresses cause no significant distortion in the piping. Peak stresses are the highest stresses in the region under consideration and should always be taken into consideration in fatigue and fracture mechanical calculations. Loads to be considered in the piping design. When we are performing the piping at stress analysis, we need to consider this forces. First of all, the sustained load based on the code name, which is the dead weight plus the internal pressure. The dead weight load is the sum of the weight from pipe containing insulation, flanges, bolts, teeth, bands, valves, and valve actuator. Sum to it the static end cap pressure load caused by internal pressure exposed to the cross-section area of the piping internal diameter. The thermal expansion, the effect of temperature changes in the piping system, including the parameters for analysis and operational mode effect. This is why we need the operational modes. The concept of secondary stress effect, stress range, and equivalent thermal cycles and fatigue is addressed. In the piping codes, you will find something called temperature range, pressure range, and stress range. This is used for calculation of the fatigue, statically calculated for the fatigue. So you need to know exactly what's the meaning of stress range and pressure range and stress range. Seismic. The effect based on the ASME P31.3, this was the paragraph mentioned in it. The effect of the earthquake loading shall be taken in account in the design of the piping. This analysis consideration and loads may be as described in ASCE 7-10 authoritativity, authoritativity, local si- seismological data. Sorry for mispronouncing it. Seismological data may be also be used to define or refine the design earthquake loads. This is the paragraph of the code. Static seismic analysis require that seismic G's value be calculated and input to the software. The G's value is computed using different civil codes based on the client's requirement, by the way. It's not only the ASCA 7 is used based on the requirement of the client, especially in seismic. Wind load. Also, this paragraph or the slides had been quoted from the ASME P31.3 and ASME P31.1 have the same paragraph more or less with some difference. The effect of wind load shall be considered in the design of exposed piping. The analysis consideration and loads may be described in ASCE 7. Authoritativity local meteorological data may also be used to define or refine the design wind loads. Hydrostatic test weight calculation. When steam or gas piping system is to be hydrotested, the effect of the weight of water and hydrotest pressure on the system and its supports must be considered, since it's possible to overstress the pipe or to overload a support and even cause it to fail. Hydrotesting is performed with all travel stops or pens on the spring hangers securely installed. What mean if you have springs, expansion joint, any flexible part in the system, you need to lock it. You lock it either by rod or you lock it either by structure support. Why? Because this part, when you studied the system, you studied with ignoring any flexibility in the system, and the hydro test in the software does not consider that this part is flexible. If we are doing a dynamic analysis or enter in the dynamic analysis, you have 4 calculations which you are using in the dynamic analysis. Model analysis, harmonic analysis, response spectrum analysis, time history analysis. Model analysis is mainly used for predicting the natural frequency of the system. So model analysis, you can consider it's something in between the static analysis and the starting of the dynamic analysis. Harmonic analysis mainly are used to predict the vibration, and you cannot perform the harmonic analysis without having a modeling analysis. Response spectrum mainly used for seismic studies, and time history analysis usually are used for the pressure relief valves or anything that need time history to be studied that have a time history. My references for this video was ASME P31 2018, ASME P31.3 2020, the Piping Stress Engineer book, and it's very good book for Lang Ching and Bing, of course. Bechtel Design Guide for Piping Stress Analysis, Bechtel Piping Stress Analysis Engineering Manual, Introduction to Piping Stress Analysis for Refineries. In the end, I hope my video was helpful for you, and if you like it, please press the thumb button below. Thank you. Please stay tuned for more videos.